Hi everyone, today we will do some very good problems based on the topic of projectile motion. Last time I did a problem called hunter monkey problem. It was quite interesting, so we will continue with more problems. Okay, before we start solving problems, let us discuss some important concepts and formulae in this topic. Imagine I choose ground along the x-axis and the y-axis is vertically upwards. So I'm showing you clouds here and then birds are flying, so that you know that this is vertically up. Gravity, we all know, acts vertically downwards, so the acceleration due to gravity is g. Now you know that since the acceleration is completely along y-axis, what will be the x component? It will be 0 because a vector along y-axis will not have x component, right? So please remember, when there is motion due to only gravity, the x component of acceleration will be 0 and y component of acceleration will be this g itself, right? Now it is downwards, try to remember, so that if you choose upward direction positive, you have to put minus g. And if you choose downward direction positive, you can write plus g. Now, at time 0, a particle is at origin and it is given a initial velocity of magnitude u. So, u represents the initial velocity at what angle? Theta. Now, will the particle go straight? Obviously no, because there is acceleration due to gravity. There is a force. So, therefore, the path of the particle will change and it will follow a path something like this. So this path is what we call parabola. Now when the particle is at this point, what will be its x coordinate? This will be the x coordinate. And what will be its y coordinate? This will be the y coordinate, right? So from here to here, that represents your x coordinate, and from here to here this represents your y coordinate. The relation between y and x. So if you can give me y as a function of x, then what does it mean? It means for any x, if I can calculate y using this formula, then I will know the coordinates of the particle. Once I know the coordinates of the particle, I will know the path of the particle. So whenever you write y coordinate as a function of x coordinate, that is called equation of path. Equation of path. Because once I know for every x coordinate, if I am able to calculate y coordinate, then it means you know each and every position of the particle. Once you know each and every position of the particle, you obviously know the path. Now, for projectile motion, if you do the derivation, you will get y equals to tan theta x minus g by 2u square cos square theta times x square. So this is the equation of your projectile. Y equals to, this tan theta can be written as a and this whole bracket thing I can write as b. So this is the equation of your trajectory. When you write y in terms of x, a represents this constant tan theta and b represents this constant which has g 2u square cos square theta. Okay. When is this equation useful? This equation is useful when you want to relate the horizontal distance covered by the particle with vertical distance covered. Now, try to see that when the particle went from here to here, it will take some time, right? So here the time is, let us assume t. Then from here to here, if I remove this theta, then this vector is your displacement vector, isn't it? Displacement vector is the shortest distance from initial position to final position. So this is your displacement vector. You can see this displacement vector will have one component here along x-axis and one component here along y-axis. So you can see this is your s x and this is your sy. So if you observe carefully, this x is nothing but displacement along x, isn't it? See, this x and this sx are matching. Similarly, this y coordinate and sy are matching. So this represents the y coordinate of the particle, which is also the y component of displacement. Okay. Now, if your particle completes a parabola where the initial position, let us call this position A, and the final position B, if these two lies on the same horizontal line, if this point and this point lie on the same horizontal line, then this horizontal distance covered is called range. The time taken from here to here. So if here the time is 0 and when it reaches here the time is capital T, then capital T is called time of flight, and as it goes like this, you can see the y coordinate reaches maximum value and then again the y coordinate decreases. So here you can see your height traveled is maximum height. So we have some standard formulas for these three quantities. Let me mention quickly to all of you. The time of flight is given by the formula 2u sine theta by g, where u is the initial velocity in magnitude and theta is the angle of projection. The maximum height is u square sine square theta by 2g, and your range formula is u square sine 2 theta by g. So these are the three standard formula for time of flight, maximum height and range. Now we can also write this formula in terms of components of initial velocity. If you look carefully, your initial velocity is given at an angle theta with x-axis. So you can see this will have two components. Here ux is the x component of initial velocity and this is the y component of initial velocity. And you know that this is the adjacent side, so this will be u cos theta and this will be your u sin theta, isn't it? So you can also write time of flight as 2, this u sin theta can be written as uy. So time of flight is 2 uy by g. Similarly, the maximum height is u square sine square theta. So if I square this u square sine square, then this will become uy square, isn't it? So in place of this I can write uy square by 2g. Observe something very important. The time of flight and maximum height depends only on the y component of initial velocity. It does not depend on the x component of initial velocity. So try to remember that part, very important. Okay, so your time of flight and maximum height depends on y component of initial velocity only. Now this range, how I can write this sine 2 theta, I can also write as 2 sine theta and cos theta, isn't it? Now this 2 let me write separately here, and this u sine theta I can write as this one u cos theta and then one more u sine theta divided by g, right? So u into u would be u square. Now in place of this u cos theta I can write ux, and in place of u sine theta I can write uy. So the range can be written in terms of components of initial velocity. How? 2 ux uy divided by g. Okay. Now at time 0 the particle was thrown from the origin, right? After time t, let us assume the particle is here. Then its final velocity will be in the direction of tangent, right? We know already that instantaneous velocity is always tangent to the path at the given point, isn't it? So this is your final velocity v. Now if I want to calculate this final velocity, directly we cannot write v equal to u plus at, remember. So we need to use the equation v equal to u plus at first for x component and then I have to use it for y component, isn't it? because this is two-dimensional problem, right? 2D problem. Now, you can see this Vx will have one component here Vx, this V will have one component Vx and one component Vy. Now, this angle here you can see is slightly smaller than this angle. So let us call this angle as phi. Right, so this phi, I hope you understood. This is the final velocity. So that final velocity makes an angle phi with the x-axis. Now, you know that there is no acceleration of gravity along x-axis, right? Gravity has no role along horizontal direction. So Ax will be 0. That means in projectile motion, Vx is always equal to Ux. And you know that Ux is u cos theta, right? What about Vy? Well, Vy will become Uy is u sin theta, right? This square I had put before. So this Uy is u sin theta, which is upward. So for upward, I have taken positive. So acceleration of gravity along y-axis is downward. So I have to put minus g into t. So this is how you have to find x component of final velocity and y component of final velocity. Of course, the time has to be mentioned. So if they give you the time, you can substitute the time here, calculate the y component of final velocity, and then once you know Vx and Vy, how to find the magnitude of the velocity? Root over Vx square plus Vy square, right? And if somebody will ask you to find this angle phi, don't confuse with this angle theta. So if you want to calculate this angle phi, you can see this is the x component Vx and this is the y component Vy, isn't it? So I can write tan phi as equal to Vy divided by Vx. And Vy you know is u sin theta minus gt, and your Vx is your ux, which is u cos theta. So this formula can be used to find the angle made by the final velocity after time t, with which axis the angle is made with x-axis, right? Now let us say the particle goes from here to here in time t. Then the actual displacement is this, right? Then this will be your x component of displacement sx, and this will be your y component of displacement sy. As I have shown you before, this sx is also the x coordinate because the particle starts from origin, and this can be also written as the y coordinate. Now, suppose I want to calculate sx, then what formula I should use? uxt plus half ax t square. But you know that because our gravitational force is along y-axis, there is no acceleration along x-axis. So there is no acceleration along x-axis. So your sx will be equal to uxt, and ux is your u cos theta, right? Similarly, if somebody wants you to calculate the y component of displacement, what formula you will use? uyt plus half ay t square, right? Now, two things about range you need to remember. Suppose I say you cannot change the speed, only the angle. Then at what angle should you throw so that the range is maximum? The answer is simple. The range will be maximum when the sine function is also maximum, and sine maximum value is 1, right? So this will be 1 when this angle of 2 theta is 90 degree. And if 2 theta is 90 degree, theta will be 45 degree. So at 45 degree, if you throw a particle with the horizontal, then the particle will make maximum range. And what is the value of that maximum range? Just put sine function as 1. So you will get u square by g, isn't it? Also, your range will be same for two complementary angles. Complementary angles means if you add them, you should get 90 degree. So for angle theta and for 90 degree minus theta, the range will be same. So these two things you need to try to remember. Okay, let us start with the first question. It says the initial velocity of a projectile is given as u bar equals to 3i cap plus 4j cap in the units of meter per second. We need to find the time of flight, the height, the maximum height, the range, and the equation of path. Sometimes it is called equation of trajectory. Now, you can see they have not given the initial velocity as a number. They have not told that the initial velocity is 10 meter per second at an angle of 30 degree. So neither they have given u directly, nor they have given you theta. What they have given you? They have given you initial velocity in vector form. Now you know that when you write initial velocity this way, this is your x component ux and this is your y component uy, isn't it? And already we know how to write all these three quantities in terms of components of initial velocity, right? So we will do that way. That way, if you do, the problem will become very simple. So time of flight formula was 2u sine theta by g, but I will write u sine theta as uy, isn't it? So this way, if I solve, the problem will be easy. So what is the y component of initial velocity? 4. G, let me take approximately 10. So this will be 8 by 10, 0.8 seconds, right? What about the maximum height? The actual formula that we wrote in terms of u and theta is u square sine square theta by 2g, which can be written as uy square divided by 2g. So uy is your 4, so this is 4 times 4 divided by 2 into 10. So 2 2s are 4, so this will be also 0.8, but this will be meters because this is height. And the range formula was 2ux uy divided by g, right? So that will be equal to 2 into ux is your 3, uy is 4 and g is 10. So this will be 2 3s are 6, 6 4s are 24, 24 by 10 will be 2.4 meters, right? So this is how you can find the time of flight, maximum height and range if they give you components of initial velocity. Otherwise, what you have to do? Otherwise, you have to find u first using this formula. First, you have to find u. After finding u, you have to find theta using this formula. Tan theta is uy by ux, isn't it? So using these two formula, you have to find u and theta. After finding u and theta, you have to calculate this tree if you use the formula of u and theta. But if you can remember these three formulas in terms of components of initial velocity, then aram se we can solve it, right? Now we need to find equation of path or equation of trajectory, which is y equals to tan theta x minus g divided by 2u square cos square theta times x square, right? Now here theta is not given in the question, u is also not given. So as I told you before, first let us find u. So u is root over ux square, which is 3 square, plus uy square, which is 4 square, right? So that will give you 5. So we found u immediately by using root over ux square plus uy square formula. Similarly, the angle of projection tan theta is uy divided by ux, right? So tan theta will be equals to uy is your 4, this is ux, right? And ux is your 3. And remember, here we need tan theta. We also need cos theta. So if tan theta is 4 by 3, it means if you draw a triangle here, then tan theta is opposite by adjacent. So this is your 4, this is your 3 and this is your 5, isn't it? So cos theta will be what from this triangle? Cos theta will be adjacent is 3 divided by hypotenuse, which is 5, right? So we know all the quantities which we need in order to write the equation of path. So what will be your equation of path now? Y equals to tan theta. Tan theta is 4 by 3. So 4 by 3x minus g, I will take approximately 10. 2 into u square, u is 5, so this will be 25 into cos square theta. This is your cos theta. So if you square it, it will be 9 by 25, isn't it? So we will substitute here 9 by 25 times how much? X square. 25 gets cancelled with 25. This is 2 5s are 10 here. So the equation of the path is 4 by 3x minus 5 by 9 x square. So if this comes as a multiple choice questions, then you may get 4 options with 4 different equations. The one which is this one you should take. Right? Let us see the next question. It says the horizontal range of a projectile fired at an angle of 15 degree is 50 meter. If it is fired with the same speed at an angle of 45 degree, its range will be. So they have given you the range as 50 meter when the angle of projection is 15 degree. They want you to find the range. Let us call this R dash when the angle is 45 degree. So we know the formula for range is equal to u square sine 2 theta divided by g. Right? And when you change the angle, let me call this angle theta dash. The new range will be u square sine 2 theta dash divided by g. Now why I wrote the same u? Because in the question they told the initial speed is same. The speed is same. So if I divide these two equations, r dash divided by r, you can see u square will cancel, g will cancel, isn't it? So in the numerator of r dash you will get sine 2 theta dash divided by sine 2 theta. Now theta dash is given 45 degree. So here you put 45 degree. And theta is given 15 degree, right? So 2 into 45 will be sine 90. And 2 into 15 will be sine 30 degree. Sine 90 degree is 1, sine 30 degree is half. So if you cross multiply, r dash will be equal to, this 2 will go up and then you cross multiply. So r dash will be 2r. Initially the range was 50, so the answer is 100 meter. Right? Let's see the next question. It says a particle is thrown with a speed u at an angle theta to the horizontal. When the particle makes an angle phi with the horizontal, its speed changes to v. We have to find relation between v, u, theta and phi. Okay. So here the particle starts with velocity u at angle theta, and after some time its velocity, which is v, makes an angle phi with horizontal. We need to relate this two quantity with this two. Now how to do that? Well, we know during projectile motion, if I consider x-axis as horizontal, then we know there is no acceleration along x-axis. So your final velocity along x-axis and your initial velocity along x-axis must be same. Right? So what is the x component of this velocity? V cos phi. Right? And what is the x component of initial velocity? U cos theta. Isn't it? So your v will be equal to u cos theta divided by cos phi. And 1 by cos phi can be written as secant phi, right? So this would be the answer. Let's see the next question. It says the ranges and heights for two projectiles projected with the same initial velocity, they should say initial speed, at angles 42 degree and 48 degree with the horizontal r, r1, r2, h1 and h2 respectively. So the ranges are r1, r2. The maximum heights are h1, h2 for what angles? 42 degree and 48 degree. Choose the correct option. So you can see these two angles, if you add, you will get 90 degree, isn't it? That means they are complementary angles. So if they are complementary angles, then by adding you will get 90. And for complementary angles, we know the range is equal, isn't it? What about maximum height? Well, maximum height is u square sine square theta by 2g. They told u is same for both the particles. So whichever will have more theta will also have more sine theta, because sine is increasing function of angle, right? Sine increases with angle. So 42 degree is more or 48? 48 degree is more angle. So sine of 48 degree will be also more. So H will be more for theta 2. So H2 will be greater than H1. Right? Let's see the next question. It says two particles are projected from the same point with the same speed at different angles theta 1 and theta 2 to the horizontal. They have the same horizontal range. So they are saying the range is same. Their time of flights are t1 and t2 respectively. So here the range is given to be same, right? And we know that if range is same for the same initial speed, then you know that the angles must add and give you 90 degree. So it's very clear, first option is correct. Now what about the time of flight? They are saying t1 and t2 are the time of flight for the two angles. Time of flight for the first angle will be 2u sine theta 1 divided by g, and time of flight for the second angle will be 2u sine theta 2 divided by g. Remember, they told the initial speed is same. So if you take the ratio of t1 and t2, you will get 2u and g will cancel. So sine theta 1 divided by sine theta 2. Now if I bring this sine theta 1 this side and t2 that side, you can see option D is also correct, right? If you or you just cross multiply sine theta 1 here, t2 here, and this will match with this. So option D is correct. What about if I want to write only in terms of theta 1? Then from here you can see what is theta 2? 90 degree minus theta 1. So let us substitute for theta 2. 90 degree minus theta 1. This will be cos theta 1, right? Sin 90 minus theta is cos theta. So this is cos theta 1. Sin theta 1 divided by cos theta 1 will be tan theta 1. That means this is also correct. Now what about I want to write in terms of theta 2? To check this option also, we know that t1 by t2 was sin theta 1 divided by sin theta 2. Right? Let me now substitute for theta 1. What is theta 1 from here? Theta 2 will go this side. So it will be 90 degree minus theta 2, which will be cos theta 2. Cos theta 2 divided by sin theta 2 will be cot theta 2. That means this is not correct. So A, B and D. These three options are correct for this question. Let us now do one interesting question. Two particles A and B are thrown from the same height. The small gap you can neglect. Okay. So both the particles are at same height and they are thrown horizontally with velocities 2 meter per second and 4 meter per second in magnitude. Now, which particle will reach the ground first if they ask? Then the answer is both particles will reach the ground at same time. Now why will they reach the ground at the same time? Some people think that this is moving faster, so this should reach early because it is moving fast. But please understand, even if it is moving fast, it will cover more horizontal distance. Okay, so this will travel this kind of path and this will travel this kind of path, the second one. If you remember, we discussed before that time of flight depends only on the y component of initial velocity, and you can see both of them have same y component of initial velocity. This also does not have y component of initial velocity. This also does not have y component of initial velocity. So y component of initial velocity is 0 for both of them because both the particles are thrown horizontally parallel to x-axis. Right? I am assuming this as x-axis. So since uy is 0 for both will take same time to reach the ground. You can check with the formula also. Sy equals to uyt plus half ay t square. So if I use this equation, you can see both the particles have 0 initial velocity along y-axis. So y component of initial velocity is 0 for both. Now, whether you choose this particle, this is the displacement, or this particle, this is the displacement. you can see the y component of displacement is same. This is the x component of displacement for the first particle, and this is the x component of displacement for the second particle. But y component of displacement is same, right? I hope you are understanding. The particle was thrown this way, so it went this way. So this is the actual displacement. This is the y component of displacement. This is the x component of displacement, right? So both the particles have same y component of displacement, 10 meter downwards. So let me choose downwards as positive because I want to write with plus 10. That will be equal to half. Acceleration along y-axis is g, and I am taking plus only because I have chosen down positive while writing this. So here if I take this positive, ay also is down only, so I have to write plus g. That will be 10 equal to g by 2 will be 10. This is also 10, right? This will be 5 into t square. So t square will be 2. So t will be root 2. So both the particles will take same time, root 2 seconds. Now what if they ask which one covers more horizontal distance? Obviously the second one. Second one travels this much horizontal distance. So what will be the horizontal distance for the first particle? This is your Sx. That will be your uxt. Uxt. Half ax t square, no need to write because there is no acceleration along x-axis. So no need to write half ax t square. Even if you write, you have to put 0 here, right? Now what is ux for the first particle? For the first particle, the x component of initial velocity is 2. Time taken was root 2, right? And for the second particle, what was the x component of displacement? 4 meter per second. So 4 into t is root 2. So if they ask you this gap, x2 minus x1, that will be equal to 4 root 2 minus 2 root 2. That if you take 2 root 2 common, you will get 2 minus 1. And then 2 minus 1 is 1. So the answer is 2 root 2 meters. Right? Let's do one interesting question. Two particles have same initial speed and same range, but different angles of projection. That means if the range is same for same speed, then it means the two angles must be complementary angles, right? If one is 30 degree, other should be 60 degree. If one is theta, other should be 90 degree minus theta. If T1 and T2 be the time of flights, then find the product T1 and T2 in terms of the range R. What is T1, T2? Time of flights for the two particles. Okay, it should be mentioned that if T1, T2 be the time of flights of the two particles, then we have to find the product T1 and T2 product in terms of range. Let's start. Now we know since range is same, it means the two angles are complementary. So if one angle is theta, other angle is 90 degree minus theta, isn't it? So what will be time of flight T1? 2u sine theta divided by g. And what will be time of flight for the second one? 2u sine theta. What is theta here? 90 degree minus theta divided by g. That will be 2u cos theta divided by g. Isn't it? Now if you take the product of T1 and T2, 2 into 2 will be 4. U into u will be u square sine theta cos theta divided by g into g will be g square. Isn't it? When you multiply T1 and T2. Now we need to bring range. So what I will do, this 4 I will write 2 into 1, 2 I will put here. Okay, and this g square I will write g into g. Now this 2 sine theta cos theta is nothing but sine 2 theta. And what is u square? This is u square, right? U square. What is u square sine 2 theta divided by g? That is nothing but range. So T1, T2 is nothing but 2 times this whole thing is r divided by this g. One extra g will be there. So When you take the product of the time of flights, you get 2 times range divided by g, because this whole thing is range, right? This is range. U square sine 2 theta divided by g. Okay, see the next question. It says a helicopter is flying horizontally with a speed v at an altitude h, has to drop a food packet for a man on the ground. What is the distance of helicopter from the man when the food packet is dropped? Let us assume this is the helicopter which is moving with speed v horizontally. Now it drops a packet here. Now remember, even if you are dropping, it will not have zero speed because it is dropped from a moving helicopter. So whatever is the speed of the helicopter, that will be also the speed of the packet when it starts. So our packet will start with a initial velocity same as the helicopter, which is v they have given. And then with that speed it comes like this and reaches the man. They are asking you to find the distance between the packet and the man when it was dropped. Now this is the vertical distance covered, h, and this is the horizontal distance covered, which let me call x. Now h is there in the option. We need to find this x. Once I know this x, I can easily find this distance between the packet and the man when the packet was dropped. So this x, how to find now? Horizontal distance, it is sx, right? So sx equals to uxt. Here your sx is x itself and ux is the initial velocity along x-axis, which is v, into t. T is the time taken. Now to find the time taken, let me use sy equation. Uyt plus half ay t square. Your uy is 0 because the packet starts horizontally. So y component of the initial velocity of the packet will be 0, right? Sy, this is the vertical displacement covered, this is the horizontal displacement covered, right? So this is your sy and this is your sx. If I call this as x-axis and this has y-axis, that you have to understand, right? So what is your sy? H. Remember, it is downwards because the packet is coming down. So this will be the y component of displacement. This will be the x component of displacement. Y component of displacement, x component of displacement. This is the actual displacement. So since it is downwards, let me choose downward direction, positive, and write plus h. Half. Acceleration due to gravity along y-axis is plus g because I have chosen downward direction positive, right? So your t will be equal to root over 2h by g, right? Just cross multiply 2h and g. Then if I substitute this t here, what will be my x? V into t, root over 2h by g. So now this distance, if I want to calculate s, that will be root over h square plus x square. Now the option has h. I need to substitute for x. So substitute for x here. What will you get? Root over h square plus x square will be v square 2h by g. The next question says the trajectory of a projectile in a vertical plane is y equal to alpha x minus beta x squared, where alpha and beta are constants and x and y are respectively the horizontal and vertical. So x is horizontal distance, y is vertical distance of the particle from the point of projection. The angle of projection is theta and the maximum height attained, capital H, are respectively given by. So they want angle of projection and formula for maximum height. So this is the equation given. They want the angle of projection and maximum height. The answer should be in terms of alpha and beta. Now when we wrote our equation in the discussion of the theory, I wrote here ax minus bx square. Okay. Now how to find theta? Well, compare this formula with our standard equation. Tan theta x minus g by 2u square cos square theta times x square, isn't it? So if you compare these two, it is very clear that alpha will be tan theta. This alpha should be tan theta. So therefore theta will be what? Tan inverse alpha. We need to now find this maximum height. Okay. Now one way you can do is, if you compare these two, then you can see beta will be equal to g divided by 2u square cos square theta, right? And this is tan theta is alpha. So this is alpha equal to tan theta. This is beta equal to g by 2u square cos square theta. Now the formula for maximum height is u square sine square theta by 2g, isn't it? So from here u square will be g divided by 2 beta cos square theta. So in place of this u square, let me substitute here. So I will get g divided by 2 beta cos square theta into here sine square theta divided by this 2g, right? This 2g is also there. So you can see g gets cancelled, and this will be 2 into 2 will be 1 by 4 beta sine by cos will be tan theta, so it will be tan square theta. And you can see tan theta is alpha, so tan square theta will be alpha square by 4 beta, right? So what is the maximum height? Alpha square by 4 beta. Now there is another way to find the maximum height. Remember, they told y is your vertical distance. So when the height is maximum, your this vertical distance, your y will be maximum, right? So when y is maximum, which is nothing but capital H, you know from calculus that whenever a function is maximum for a given value of x, then at that point your derivative dy by dx should be 0, isn't it? So if you guys remember, if your graph looks like this, then at this point if you draw tangent, it makes acute angle. So here your slope dy by dx is positive. Here if you draw tangent, your slope was tan theta, which is dy by dx is negative. Whereas at the point where your y is maximum, here, if you draw the slope, right, the tangent, then the tangent will be parallel to x-axis. So at this point, your dy by dx will be 0. So already I have discussed this in the concept of maxima minima. Okay, please check. So when y is maximum, dy by dx should be 0. So take the differentiation of this. d by dx of alpha x minus beta x square equal to 0. So differentiation of the first term, if you do, alpha is constant, it will come outside, dx by dx, minus beta will come outside, dx square by dx, that should be 0. Now dx by dx is 1, and differentiation of x square is 2x equal to 0. So take this one that side, you will get alpha equal to 2 beta x. So x will be alpha by 2 beta. That means this is the x coordinate where your y will be maximum. So just substitute this x here. So therefore y maximum, which is your maximum height, alpha into alpha by 2 beta minus beta into alpha square. If you square this, you will get alpha square by 4 beta square. So this will be alpha square by 2 beta minus 1 beta cancels, alpha square by 4 beta. If you take alpha square by beta common, you will get 1 by 2 minus 1 by 4. So that will be alpha square by 4 beta. The same answer which we got before, right? Let's see the next question. It says the projectile motion of a particle of mass 5 gram is shown in the figure. The initial velocity of the particle is 5 root 2 meter per second and the air resistance is assumed to be negligible. The magnitude of change in momentum between point A and B is x into 10 power minus 2. We have to find the value of x to the nearest integer. Now, this is the path of the projectile as shown in the question. Please understand that this point A and this point B are in the same horizontal level. Therefore, whatever speed it has here, same speed it will have here also. Okay, that is because there is no air resistance. So if you throw something with 10 meter per second upward, and if there is no air resistance, then while going up, what happens? Gravity will decrease the speed, then it will stop. But while coming back, what will happen? Gravity will give you back the speed. So while going up, you lose speed. While coming back, you will get the same speed if there is no air resistance. So while going this way, the y component of speed will decrease, but while coming back, the y component of speed will increase. And you know x component of this velocity doesn't change. So therefore, by the time our particle reaches the same level, this u will be same. And since u cos theta and u sin theta are also same, this theta, this angle also will be same, which is actually given in the question. Even if they don't give, you should know these two angles will be same. So now they are asking you to find the change in momentum. So let us take the components of the initial velocity. So this is u cos 45 and this is u sin 45, right? So these are your components of the initial velocity at A. At B, you see it makes the same angle with x-axis 45 only, right? Here also this was 45. So this is also 45 now also. So this will be u cos 45 and this will be u sin 45. Now if you look carefully, which component of the velocity changed? You can see the x component of velocity did not change. So due to the x component of velocity, the change in the x component of velocity will be 0. What about the change in the y component? You can see this one was u sin 45. Now it is ulta. That means the y component of velocity has changed. Now the change in momentum is equal to mass into change in velocity. But you can see the x component of velocity did not change. Only the y component has changed. Now you know that if 2 remains 2, the change is 0, like here. This and this are same, so no change. But if 2 becomes minus 2, what will be the change in magnitude? If 2 becomes minus 2. If 2 becomes minus 2, what will be the change? 2 minus minus 2, that will be 4, isn't it? If the magnitude only if I ask. So mass is 5 gram means 5 into 10 power minus 3 kg. This u sin 45 has become u sin 45. So u sin 45 up. If I choose this plus, this will be minus, isn't it? So change in velocity will be minus u sin 45 final velocity minus initial velocity. Correct? Huh? Now u was given 5 root 2. Sin 45 is 1 by root 2. So root 2 cancel. So this is minus 5. Same thing this also, u is 5 root 2. Sin 45 is 1 by root 2. So minus 5 will be minus 10. So this will be minus 5 into 10 power minus 2, right? Because this is minus 10. Now, if you want only the magnitude, the modulus, you can remove the minus sign. So the x is obviously your 5, isn't it? So your x should be 5. Let us see the next question. It says the upper end of the string of a simple pendulum is fixed to a vertical z-axis. So the upper end of a pendulum is fixed on vertical z-axis. So this time the vertical axis is not y-axis, it is z-axis. So please remember, gravity is this time along z-axis and set in motion such that the bob moves along a horizontal circular path of radius 2 meter parallel to the xy plane 5 meter above the origin. So the pendulum is made to move in a circle which is 5 meter above the origin. The bob has a speed of 3 meters per second. The string breaks when the bob is vertically above the x-axis and it lands on the xy plane at the point x, y. We have to find the x and the y coordinate. So this diagram explains the question. This is the pendulum whose bob is moving in a circle. The plane of the circle is parallel to your xy plane and the height is 5 meter. So the circle is at a height of 5 meter from the origin. Okay. Now they told when the particle is above the x-axis. When the particle is above the x-axis, the string breaks. So once the string breaks, what will happen? Whatever velocity this has, and you know in circular motion the velocity is along the tangent. So whatever velocity it has, which was given 3 meter per second, with that velocity it will continue. But because there is gravity downwards, the particle will follow this kind of path, right? And it will follow somewhere here. So they want you to find the coordinates, the x and y coordinates of the point where it lands. Now, it is very clear that the particle will land at a point which is the intersection of this line and this line, isn't it? Now, this is parallel to your x. So this is your x coordinate and this is parallel to your y axis. So this is your y coordinate. Now, if you observe carefully, this x should be same as this x and that x should be same as this x, and that x is also nothing but the radius, right? This is center and this is the circumference. So from here to here is the radius. Velocity, let me write here. So again I am telling you, this x is nothing but this x and that x is your this radius. So x coordinate is 2 meter. Now how to find the y coordinate? Let us see this whole diagram from here. So from this side, if I see this dot line, let me show this way, right? And this dot line, let me show this way. Now this dot line is your line parallel to y axis and this dot line is parallel to your z axis, right? Now the particle's initial velocity is along y axis, you can see, right? So initial velocity is along y axis, and because there is gravity this side, gravity is along always vertical direction, downward direction. So because of this gravity, acceleration of gravity, the particle will follow this path. So this is the point here. Now I need to find this y and this is your z. Now usually this kind of problem we used to write here y and here x, isn't it? And if the particle is thrown this way, it will go this way. This was your y component of your displacement. This was your x component of displacement, isn't it? But here things will change. Your horizontal is not x. Here your horizontal is y. And your vertical here is z, not y. Okay, so one small change we have to do. So try to remember that. So to find y, the formula for y I can write uyt plus half ay t square. So y will be, now uy, you can see this velocity, initial velocity is completely parallel to y axis. So this itself is your y component of velocity because it is parallel to y axis. So this itself is your uy, isn't it? So this is your 3. But the time taken from here to here we don't know. What about ay? Well, your acceleration is completely along z axis. So what will be its y component? If a vector is along z axis, it cannot have x or y component, right? So since the vector is completely along this axis, there cannot be any component. And we also know already that acceleration due to gravity doesn't have any role horizontally, and this time your y-axis is horizontal, so there will be no component of acceleration due to gravity along y. So this ay will be 0. So we need to find t in order to find y. So for that, let us use this z equation also. So z will be equal to uzt plus half az t square. You can see the particle was thrown parallel to y-axis. So initial z component will be 0, right? So initial z component of velocity is 0. So this will be half. And what is the acceleration along z-axis? Acceleration along z-axis is your g itself into t square. Now what is the z? You can see when the particle comes from here to here, this is the actual displacement. This is the z component of displacement, right? Which I wrote here z. Now that z will match with this 5 meter, isn't it? Because this circle is parallel to xy plane. So this 5 meter and this z should match. So this z is nothing but 5. And it is downwards, and I have written plus 5. So downwards I have chosen positive, plus 5. Half g also I have chosen plus g downwards. I did not write minus, right? Into 10 into t square. So 2 5s are 10. So from here t square will be 5 divided by 5, which is 1. So therefore t will be square root of 1 is 1 itself. Then substitute this 1 here. You will get y as 3 into 1 equal to 3 meter. That means when the particle reaches here, your y is 3. And this x already we discussed is this, and which is this, and that is the radius, which is 2 meter. So x is 2 meter, y is 3 meter, right? Let's see the next question. It says a railway compartment is 16 meter long, 2 meter wide and 3.2 meter high. It is moving with a velocity v. A particle moving horizontally with a speed u perpendicular to the direction of v enters through a hole at the upper corner A and strikes diagonally opposite corner B. Assume g equals to 10 meters per second square. We have to find the value of v and u. So here is a train. The length of the train is 16 meter. The height of the train is 3.2 meter and the width of the train is 2.4 meter. To make it simple, I am calling this as x-axis, y-axis and z-axis. The train is moving with a uniform velocity v in this direction. So in my case, parallel to x-axis. Now there is a hole at the upper corner A of the train. A stone enters this train this way. This way matlab parallel to z-axis, right? Because they told the velocity of the stone is perpendicular to this v. So it is entering this way. Now you know, as it enters like this, it is going to fall this way, right? Since the train is moving, according to question, by the time the stone reaches the ground, this point B reaches here. Okay, so when the stone hits the ground, it hits this point B, the diagonally opposite point. Now, how to find this u and v? That is the question. Well, one thing is very clear. Since the stone is falling this way, right, the vertical displacement of the stone will be this, which is 3.2 meter, isn't it? Imagine this is your train. Okay, so this is the hole is here. So it is entering this way. Then it will have velocity this side. But there is gravity this way, right? Because of this gravity, it will follow a path something like this. So as it follows this path, this will be your vertical displacement. And this will be your horizontal displacement, isn't it? So your vertical displacement will be 3.2 meter. So it is very clear that the vertical displacement, which is your y here, vertical axis is y, right? So your Sy is 3.2 meter downwards. So let me take downwards positive. Then acceleration due to gravity is also downwards. That is also plus 10 now, right? Because I have chosen downward positive. So let us use the equation Sy equal to uyt plus half ay t square for this vertical direction. This is 3.2. Now your initial velocity of the stone is parallel to z-axis. So a vector along z-axis will not have y component or x component. So this will be 0. Half, what is your ay? 10 into t square. So this is 2 5s are 10. So t square will be 3.2 divided by 5, which is 32 by 50. This is 25. 2 1s are 2, 2 6 are 12. So t will be square root of 16 by 25. That will be 4 by 5. So how much time it takes to reach the bottom? It took 4 by 5 seconds. Now during that 4 by 5 seconds, this B has to reach here, because this stone would have reached here, remember, if the train was not moving. Because the train is moving, this point B has to be here. That means the train, this point B in the train has to travel 16 meters. With what velocity? V. In what time? 4 by 5 seconds, right? So for the train, so displacement equal to velocity into time. So how much displacement the train has to make? Because this point of the train has to reach here. It means the whole train has to travel 16 meters. By the time the stone reaches the ground. With what velocity? We don't know. And the time taken is the same as the time taken by the stone to reach the ground. 4 by 5. So 4 4s are 16. If you cross multiply, 20 meters per second. Also, because the stone reaches here, the distance covered by the stone parallel to z-axis will be 2.4 meter. So this is the vertical distance covered by the stone. This is the horizontal distance covered by the stone. But here horizontal is your z-axis, remember. So Sz for the stone, this is for stone, will be uz into t plus half az t square. It is very clear that the acceleration of gravity is along y-axis. So there is no acceleration of gravity along z-axis. And your initial velocity is completely parallel to z-axis. So that itself we have to calculate, right? And your displacement parallel to z-axis by the time it reaches the ground is 2.4, right? This is 2.4, isn't it? If this is 2.4, this is 2.4, this is 2.4. And the time taken was 4 by 5. So this is 4 6 are 24. So 0.6, if you cross multiply, 3 meters per second, right? The next question says two particles are projected in air with speed v0. So both the particles have same initial speed v0 at angles theta 1 and theta 2, both are acute to the horizontal. If the height reached by the first particle is greater than that of the second particle, then tick the right choices. I have given the two particles have different angles of projection theta 1 and theta 2, but both the particles have the same initial speed. So v0 is same, which we wrote before as initial speed as u, right? And they also told maximum height of the first particle is greater than the second particle. Now we know the formula for maximum height is u square sine square theta by 2g, which I can also write uy square by 2g, isn't it? So now you can see that since maximum height is more for the first particle, this uy should be more for the first particle. So uy for the first particle should be greater than uy for the second particle. Now uy formula is what? U sine theta, but u is same. So uy for the first particle will be u sine theta 1, and for the second particle u sine theta 2. U is same, so it will cancel. And since you all know sine function increases with angle, right? Sine 0 is 0, sine 90 degree is 1. So when angle increases, sine function also increases from 0 to 1. So if this sine function is more, angle also should be more than this angle. So theta 1 will be greater than theta 2. So option A is correct. What about time of flight? Now you know the formula for time of flight is 2u sine theta by g. U sine theta you can write uy. And which one has more uy? First particle has more uy. So if first particle has more uy, this also will be more for the first particle. So this is also correct, isn't it? Now the formula for range is r equals to u square sine 2 theta by g, which you can write as 2ux uy divided by g. Right? So now you know that ux is u cos theta, uy is u sine theta. And you know first particle has more theta than the second particle, both are acute. Now, if theta 1 is greater, then sine theta will be also greater. So uy for the first particle will be greater than uy for the second particle. Because when theta increases, sine function also increases. So when theta increases, sine theta also increases. So if sine theta is more, uy will be more. And theta is more for first particle, so uy is more for first particle. But when it comes to ux, this is u cos theta. Now cos theta is not increasing function of angle, it is decreasing function, because cos 0 is 1, cos 90 is 0. So you can see, students, when the angle increases, cos value decreases. So therefore we can say ux for the first particle is actually less than ux of the second particle. Right? So this is more for the first particle, whereas this is ux is less for the first particle, this is more for the first particle. So now we cannot decide whether this will be more or less for the first particle, because even if one quantity is more, other quantity is less. So therefore it is not possible to decide that the first particle will have more range or less range unless they give you the specific angle. If they give you the specific angle, we can substitute and calculate and then decide which one will have more range. But without the angle, this is not possible to decide. Now what about the total energy? Here in the option they have told that the total energy of the first particle is greater than second particle. They are using capital U as the symbol. Well, you know the total energy is kinetic energy plus potential energy, right? Kinetic energy plus potential energy. But since they are not mentioned the height of the particle from where it starts, we will assume both the particle starts from the ground. So if both the particle starts from the ground, potential energy will be same for both the particles because the height is same. What about kinetic energy? Kinetic energy is half mv square, and v square is a scalar quantity, remember. Square of a vector is a scalar, because if you take a vector and then you take dot product with the same vector, in dot product what did we learn? A bar dot b bar is ab cos theta. So what will be a bar dot a bar? A cos, what is the angle between a bar and a bar? Same vector, so cos 0. So that will be a square, right? So square of a vector is dot product of the vector with itself, and we all know dot product is scalar. So this quantity does not depend on angle, it only depends on the speed. And since they told both the particle have same speed, it means both the particle will have same kinetic energy. And since they both started from the same point, since it was not mentioned, I will assume they started from the same point, they also will have same potential energy. So kinetic energy is same for both, potential energy is same for both, so total energy will be same for both, right?